Yeah.
Yes. Okay. So this is our autonomous guide robot. So basically, this project explores the development of an autonomous robotic assistant inspired by the role of a guide dog. The goal of our project was to investigate how robotics and AI can be combined to help people navigate environments more safely and independently. Our robot uses sensors, autonomous decision making, and reinforcement learning to understand its surroundings and determine how it should move. Instead of relying on a human operator or a fixed program, the robot is designed to learn from its environment and improve its navigation decisions over time. Throughout this program, our team explored the challenges involved in creating an intelligent navigation system, including obstacle detection, movement control, communication between different softwares, and, of course, training an AI model to make decisions. So here's our problem statement. Navigation is a major challenge for many people, especially individuals with visual impairments, who may have difficulty identifying obstacles, understanding unfamiliar environments, or safely moving through crowded areas. While guide dogs provide excellent support, they require extensive training, years of preparation, and significant resources. Additionally, access to these trained dogs is limited due to cost, availability, and the time required to train the animal. This creates a need for alternative technologies that can provide navigation assistance in a reliable and accessible way. A robotic guide assistant could potentially provide support by detecting obstacles, planning movement, and helping users safely reach destinations. The challenge was not just simply making a robot move. The challenge was creating a system where the AI could understand its environment, make safe decisions, and adapt to different situations. So basically, our solution was to use an autonomous robotic guide system that uses sensors and AI to navigate an environment. The robot uses information about its surroundings through the sensors that detect nearby objects and obstacles. The information is then processed by the AI model that determines the best actions, such as moving forward, turning, or stopping. The robot uses reinforcement learning, a type of machine learning where an agent learns through trial and error. The AI receives the rewards for making good decisions, such as moving closer to a target, and penalties for unsafe actions, such as approaching obstacles or moving away from the goal. Over time, though, the robot learns navigation patterns that allow it to move more efficiently and safely. Although this prototype focuses on simulation and basic navigation, the same concepts could be expanded with more advanced sensors, cameras, and AI models. See, the thing with reinforcement learning is that it's trying to teach a child. You can tell the child to do A, B, C, and D, and you can tell the child that it will get rewarded for each action and penalties for certain other actions. But the child, which is the AI, could choose to completely ignore everything you told it and find a loophole in the system to gain points without doing the correct action. In that scenario, we'd be enforcing the wrong policy, causing lots of problems. We are the ones who are choosing the reward system, and we have to be very specific to get the results we want. Now, on to our live demonstration. But before I continue, I need to make something clear. Our original idea for this project was to use a robot called Spot the Dog, made by Boston Dynamics. The robot Spot has 12 different motors, and having an AI control all 12 motors at the same time requires extensive training. That training we did not have time for, though. We spent the first 2 weeks trying to figure out how to train it, and then once we started training, we realized that we didn't have enough time. So only this week, we switched to another robot called Epoch, which is a smaller robot that's similar to a Roomba in shape, and that's what we used for this project. And I do not actually have a complete finished model because the model is still training. So instead, I will show you how it trains and how it learns from its environment. So that's what I will show you right now. So this is the code that we used for this project. Basically, we just defined variables and hyperparameters.
Aadived, I think you're still sharing the project,
Really?
sorry, the presentation.
Oh, yeah, sorry. Wait, I'm just going to stop sharing for a second. Do you see my screen?
Yeah.
Okay. So basically, this is the code that we use for the project. So basically, we're just defining the hyperparameters, and we're just setting up the environment, setting up the code for training, defining the reward system. That's basically all this code goes over. And then now to our simulation. So I will restart training so you can see how the robot works. So right now this is the robot called Epoch, right? And one second, training already started. I wanted to explain it a little bit better. So this is our robot called Epoch. It's like a small robot, but it should get the job done. Basically, right now it's getting trained to avoid obstacles and get to this destination over here. And let's just start training to see how it works. I'm gonna put it on high speed so you'll be able to view how it works. So in the beginning, right now the robot is testing out its motors, seeing what actions will lead to higher rewards. And right now, it's just moving around just to figure out how to move. Let's just watch this for a few minutes because as time goes on, it will get closer to the destination or the red goal marker. Over here in the terminal as well, I forgot to point out, this is like the PBO updates. So basically, uh, we're as the simulation goes on and as training continues, we get these updates from the PPO agent, which will tell us how well the model is doing. So the things that you need to look out for is over here, EP raw mean. That's the score or the reward. So like how high the reward is, and then the EP len mean, 1.5. So basically, what that's saying is how long it lasts before it gets reset. And as it goes on, the reward will get higher. So right now, it's currently 91.6. That's the reward. But before it was like 35 when it started off. Yeah, 35.8. So as time goes on, this reward will get higher, and so will the time it lasts in the simulation go longer. Right now, it's exploring its environment, but as time continues, it should get farther. So basically, the reward function is defining how, like, what actions get what rewards. So in our code, it's getting rewarded for getting closer to the destination, and penalties for making unnecessary actions or colliding into obstacles. We're still early into training, so right now it's set for 200,000 time steps, and that's basically like the simulation time in the software. And right now we've gone through 28,000 time steps. So we're about a tenth of a way there.
Okay. By the time it's training itself and reaching to its target, what is the reward function looks like right now? Like, how are you rewarding the robot and penalizing it?
So basically, we can actually see that right now. 1 second. This will make it easier for you to understand. Okay. So this robot has a few distance sensors, as you can see here. And then basically once it gets like near or like uh near an obstacle, it should like remove points. But right now we're still early to training, so it doesn't realize that crashing into an obstacle is bad. So it will eventually learn that crashing into an obstacle is bad, and then learn not to do that. But 200,000 time steps isn't enough for it to learn that crashing into obstacle is bad or getting to the destination is good. So after these 200,000 time steps, we have like a base to build on. So from there, we can change the reward function and be more specific so that it can continue learning. 200 since this is 200,000 time steps, it will take a little bit longer than this time, like the time call. So I can go back to the presentation and then we can see how it ends up in the end. Is that fun?
Sure.
Okay.
Okay, so I have a few questions for you.
Yeah, sure.
in the meantime. So let's say you have to take this now into the real world. Okay. So what are
Yeah.
the main challenges that you'll face, and what are the major resources that you need?
For the main challenges, it will obviously be like the environment, because right now we're training it in a flat world with only a few obstacles, but in the real world there's gonna be multiple different obstacles and multiple different environments that it's forced to survive in.
Mm-hmm.
And on top of this, we haven't. So another part of our project that we were going to add if we had time was like a part where the robot could communicate to the user. We still haven't added that, so our model still doesn't understand that it's getting like followed by a human. It does, if that makes sense. So we need more training and more time to develop this so that it can fully be implemented in the real world.
Okay, understood. Okay, yeah. So just one last question.
Yeah.
So how do you make, because uh, the robot should have the confidence. Okay, so after a lot of training, how will you ensure that the user uh, have a lot of confidence and the robot itself has a lot of confidence into navigating the user? How will you establish that trust?
Again, it's a lot of training, right?
Mhm.
Because we want to train it over multiple different environments. So basically, in the simulation, right? Actually, I'll just show it for my code. So basically, we began training it on multiple different like worlds. So right now, we're just training it on one of the other worlds that we have with multiple obstacles. But as time goes on, I want to create multiple different environments and with multiple different obstacles, so it can learn to become more confident by being able to survive longer in these different environments.
Got it. All right. And what was the most difficult part for you to implement while making this project?
It was definitely the reward function. So basically, the problem with reinforcement learning is that, like I said before, it's like trying to teach a child how to do something. You tell it to
Mm.
do A, B, C, and D, and then it might just ignore everything you tell it and try to do its own thing. That sometimes happens because the model will find a loophole, and then, for example, if it gets rewarded for turning left or turning right or moving forward, for example, it might just continue turning in a circle over and over again because we weren't specific enough.
Okay.
So
And
that's one of the biggest challenges.
okay. And if you were to like redo the whole project, okay, what would you change? Like, how would you make it better?
So first of all, I wish we had more time to work on the project because that means we would get a better output or results. And if I could change it, I would want to do a more complex robot because our original idea was to use a robot called Spot the Dog. Like I said before, you probably know what it looks like. It's it was made by Boston Dynamics, but again, the problem was that it had 12 motors, so it was hard for the AI to control all of them and learn how to walk, turn, etc. So if I had more time and I had um more time in general, I would use that robot and train it continuously.